This is DeepSeek Harness, an open-source coding agent built around one unusual idea. Almost everything inside it is a plugin. Let us open it and see why that matters. Other agents let you add skills and tools. This goes deeper. Plugins can change the interface, the agent loop, and parts of the harness itself. That difference helped the repository reach roughly 167,000 stars in less than a week. But popularity does not tell us whether it is actually useful. So we will install it, explore the modes, build a plugin, inspect the security risks, and decide whether it is worth using beside Claude Code or Codex. Installation is straightforward. Find the official DeepSeek Harness repository on GitHub, make sure node.js is installed, and run the publish command in a terminal. In this setup, the command starts the harness locally and opens a web interface on your own computer. Once that page appears, the layout should feel familiar if you have used another coding agent. On the left are your workspaces, which are simply the folders the agent can work in. Under each workspace are the different sessions or chat windows. In the center is the prompt area. You choose the workspace, type what you want done, and then decide how much access and how much agent behavior the task needs. The first option is Standard Mode. This is the ordinary, general-purpose setting, and it behaves much like the normal experience in Claude Code or Codex. The agent can reason through a task, use its available tools, inspect files, and work through a sequence of actions. For most everyday jobs, this is the sensible place to begin. PTC mode is intended for more complicated, multi-step work. In standard mode, a long task may call one tool, return the result to the conversation, then call the next tool. PTC mode can instead create code that coordinates several tools in one go. The goal is to reduce the repeated tool call history that can swell the context during a large job. Minimal mode sits at the other end of the scale and is useful when the task does not need the full agent setup. Then there is Creator mode, which is the unusual one. Creator mode is where you describe a plugin you want, inspect the harness, and let the agent help build or change a part of the harness itself. The plus menu contains familiar / commands for compacting a conversation, exporting the session, setting a goal, changing permissions, entering plan mode, or selecting a model. The permission menu then lets you choose read-only access, workspace write access, or full access. These controls are visible before the agent begins, so you can match its authority to the job instead of granting everything by default. Because this is an open-source harness, you do not have to use the DeepSeek API. Open Settings, go to Models, add a provider, and enter the relevant API key. A provider such as OpenRotor can expose many different models through the same interface. That makes DeepSeek Harness less like one model product and more like a flexible front end for whichever models you prefer. The general settings contain a small option that is worth understanding. What should happen when you send another message while the agent is busy? Queue waits until the current work finishes. Steer lets the current tool call complete and then brings your new instruction into the run. It is a simple choice, but it changes how naturally you can redirect a long task. Now open the plugins area and the everything is a plugin idea becomes much clearer. The list represents the pieces mounted into the running harness. Beside that is the plugin configuration, where you can see which parts can be adjusted. This is not only a marketplace of optional extras. It is also a view into how the harness itself is assembled. Take the agent loop as an example. That loop is core plumbing. It helps decide how the model, tools, and results move through a task. DeepSeek Harness exposes that kind of component through the plugin architecture, including settings such as parallel tool behavior. Creator mode can take those changes further by helping you define a plugin around the behavior you want. This is the practical difference from Claude Code. Skills and hooks can approximate many useful workflows, but they normally work with the harness that Claude Code provides. Here, the pitch is that you can alter deeper pieces of the harness. That extra freedom is powerful, but it also means more setup and more responsibility land with you. Web search is a good example of the trade-off. The built-in search may expect the DeepSeek API. If you are using a different model provider, you may need to find and install another search plugin that works with it. The open architecture gives you an answer, but sometimes you have to assemble that answer yourself instead of receiving it ready to go. Community lists on GitHub already collect plugins for search, interface changes, workflows, and other features. Installation can be as simple as running a command and restarting the harness. That convenience is appealing, but it should not be confused with safety. A plugin is still code, even when the installation takes only a few seconds. This is the warning I would not skip. DeepSeek Harness is in developer preview, and plugins may receive shell access and broad access to the file system. A malicious or careless plugin could potentially read project files, environment variables, or API keys available to the process. Do not install a random package simply because its demonstration looks useful. Check the source first. Look at the publisher, dependencies, permissions, and recent changes. If you can, have another trusted tool review the code as well. Then test the plugin in a disposable workspace with limited credentials. The plugin ecosystem is one of the most exciting parts of this project, but right now it is also one of the clearest risks. Suppose you find an interface plugin that adds an effort slider. The installation may only require one terminal command, followed by a quick restart of the harness. When it comes back, the new control appears directly in the interface. Some plugins support hot reloading, while others still need a restart, so the exact behavior depends on what the plugin changes. Creating your own plugin is the more interesting demonstration. Switch to Creator mode and describe the result in plain language. For example, ask for a plugin that changes the interface into a dark matrix-style color scheme with falling characters in the background. The request is deliberately simple, but it shows the mechanism clearly. As the agent works, the session shows more than a basic chat response. You can see context being injected, the tool calls being made, and the steps used to inspect and define the plugin. At the bottom, the interface can display details such as cache hit percentage, input and output tokens, and generation speed. That visibility is useful when something does not work. Instead of only seeing a final error, you can inspect where the agent looked, what service it called, and what it tried to create. For developers who spend time troubleshooting agents, this can be more valuable than the visual plugin itself, because it turns a vague failure into a sequence you can examine. The Trajectory tab takes that idea further. It lays out the user request, injected context, assistant decisions, and tool calls as a timeline. Select one event and you can inspect a summary, a preview, or the raw details. That makes it much easier to find the exact point where a long agent run drifted, misunderstood the task, or used the wrong tool. You will also see the name Cordis throughout the interface. Cordis is the underlying framework that composes the harness. A useful way to picture it is as the chassis of a car. The model, tools, interface panels, agent loop, and other plugins are the components attached to that chassis. The harness can also export the complete session log as a zip file, with the turns and calls represented in JSON. That is another strong troubleshooting feature. You are not limited to whatever happened to remain visible in the chat window. You can take the run apart afterwards and inspect the underlying record. The matrix example may not produce a beautiful interface, but that is not really the point. It demonstrates how quickly a plain language request can become a working harness plugin. One important detail is that a newly created plugin may only live for the current session. If you want to keep it, tell the harness to save or package it before you close the session. So the two strongest reasons to try DeepSeek Harness are now fairly clear. First, its plugins can change foundational parts of the harness, not only add outside tools. Second, its trajectory and session details give you unusually deep visibility into what the agent is doing. The local, open-source design and freedom to choose models make both ideas more attractive. Should you leave Claude Code or Codex and move everything across today? Probably not. DeepSeek Harness is genuinely different, and that is a good thing, but it is still a developer preview project. A perfectly customized, partly self-improving harness is an exciting vision. Whether the time spent building and maintaining it will improve your real work is a separate question. The sensible approach is to remain tool agnostic. Keep the agent that already works for you, try DeepSeek Harness beside it on a low-risk project, and see whether the extra control actually changes the result. It is free, open source, local, and worth experimenting with. For more clear technology walkthroughs, check out Tech It Away. I will see you in the next one.